1.
All right, let's look at some more examples. Let's say we're going to go ahead and use this notation. D over dx. Now let's go ahead and combine the constant rule with the power rule, if you don't mind. We're going to do that, and you should try to work this out. Maybe pause the video and work this out. So what is this saying here? This is saying, hey, we need to take the derivative of this. And we're going to be taking the derivative of each one of these terms separately. Okay, and I think there's a theorem behind that, but all right, we'll talk about that here in a minute. But we're going to go through and take the derivative of each one of these separately. So what do we do here? We take the 2, we bring it out front. Whoops. Take the 2, bring it out front, subtract 1 from the exponent, plus, not this one here. Well, this one is, there's assumed to be a 1 up here in the exponent. We take the 1. Let me actually do some side work here on this one. I should have probably worked this one first. All right, so we take this 1, we bring it out front. And remember, we assume there's a 1 up there in the exponent. We subtract 1 from it. What do we end up with? 1x raised to the 0 power. So as you can see here, x to the 0 power is just 1. I'll go ahead and put parentheses around that. Whoa, what happened? So x to the 0 is 1, and 1 times 1 is just 1. So the derivative of x is 1. Now, would we say the derivative of a constant is? The derivative of a constant is 0. Of course, we're not going to write that, right? We're not going to write that. Okay. So as you can see here, this derivative of x squared plus x plus 3 is 2x raised to the first power plus 1. But remember, we don't put a 1 right here. Okay, we just leave it off. So it's 2x plus 1. All right, let's work another one. And we'll go ahead and use this same notation. Same notation. This time we'll say 5x squared plus 4x plus 3. We want to find the derivative. So once again, we take the 2, we bring it out front. So 2 times 5, you know what? Let's not skip any steps here. We'll just write it out. What do we do here? We subtract 1 from the exponent, and that just becomes 1, but we're not going to write it. Plus, now once again, you take the 1, bring it out front. 1 times 4 is 4. And then, of course, remember, just like we did here, this would be x to the 0. See, so we just be left with 4, and the derivative of a constant is 0. But we're not going to leave it like that. It's 10x plus 4. 10x plus 4. All right. So this time we combined the power rule with the constant rule. See this? All right. I think in the next problem, what we're going to do is we're going to find the equation to the tangent line, and then we'll call it quits on the power rule. All right, using the power rule.